Hello everyone and welcome back to Diksha Vedantu Foundation channel. Here we are discussing 99% in 99 days. Today is day 15 and I am going to discuss the rest of the part of the chapter light. So we have already completed reflection of light and spherical mirrors. Today I am going to discuss laws of refraction and spherical lenses. Very important portion of the entire chapter. Some parts you are going to study are new. For example, refraction you have studied, but you have not studied refractive index. Similarly, lenses you have studied, but lenses equation you may not have studied. Image formation by lenses are also something which you have to practice for ray diagrams, etc. So without any delay, let me start with today's chapter. That is light, refraction, mainly today's focus. So light, we have seen this animation last time as well. So spherical mirrors, spherical lenses. So now we are going to discuss about refraction. This part is already completed. Refraction, there is a glass slab, then lenses, okay, concave lens, convex lens. Then we have these are related to mirrors, these are related to lenses. Okay, out of that, glass slab is very small portion. I have not included in our discussion. But if you have any doubts, any question, you can mention that in the comment below. I can add a small video for glass slab if required. Okay, now without any delay, let's check the list of contents. Refraction of light and its laws. Then we will discuss about refractive index. Then we will discuss about lenses. Then we will discuss principal rays, image formed by concave lens first, then image formed by convex lens next. Then we will learn about lens equation, magnification, and then power of lens. Very important concept for your board exam, right? So without any delay, let's start with the refraction of light. I say too much same thing again and again, please pardon me about that. So refraction of light, it appears that when traveling obliquely from one medium to another, the direction of propagation of light in the second medium changes. This phenomenon is known as refraction of light. So you can see here there is a beautiful example that there is a pencil dipped into a water. Okay, and here it is appearing that the pencil is broken at the edge of the water. Why it is so? Because when light is traveling from one medium to another medium, okay, for oblique incidence, what happens is the ray of light, suppose the light is traveling from this medium 1 to this medium 2. Okay, at the boundary, what happens? This medium, based on how dense, how light the medium is, the ray of light changes the direction. Okay, so this happens for oblique incidence only, but for normal reflection, normal incidence, refraction does happen, but we do not observe it clearly. Okay, the speed, refraction is related to the speed of changing in the speed of light. So change in speed of light definitely happens, but we do not observe it because it follows the same path, but it goes slower or faster based on the medium. Okay, so in this case, for example, I am assuming this is air, this is water. So as a ray of light traveling from air to water, okay, it bends towards the normal. The ray of light bends towards the normal. Similarly, if the ray of light traveling from water to air, it bends away from normal. These are the two conditions. Okay, we will learn about that in a while, but let's look into the laws of refraction of light. First law, the incident ray, the refracted ray, and the normal to the interface of the two transparent media are at the same point of incidence, all lie in the same plane. So it is basically same as laws of reflection. That's why I'm not going too deep into that. So incident ray, refracted ray, and the normal drawn at the point of incidence all lie on the same planes. Okay, and in case of reflection, we studied that as a second law. In case of refraction, we are studying that as first law. Nothing to worry about. You can write that as first law, write this as second law, or this law as the second law that I am going to talk. You can write this as first law, and the law that you have studied in reflection as second law, you can write this the same order. Okay, no problem. Okay, the order does not matter, because we have to continue with the flow. Most books follow this as second law. Okay, because after this entire discussion is based on this law, so that's why this is given as second law. Okay, if they have given this as first law without proper explanation, and then first one as second law, then there would have been a break. Okay, so to continue the discussion, they have given this as second law. Nothing to worry about. What is this? The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of given color and for the given pair of media. This law is known as Snell's law of refraction. This is true for angle 0 less than I equals to less than 90 degrees if the angle of incidence and r is the angle of refraction, then sin I by sin r equals to constant. Okay, so sin I by sin r is constant. Obviously for given angle range, I will explain it in detail. So here imagine that a light ray is traveling via from A to B, and this is the incident medium. Okay, first medium, and this is the second medium. Right, this is the first medium, this is the second medium. Okay, let me denote them like that. Now from the second law of refraction, we can write that sine of I divided by sine of r equals to constant. That constant we are calling it as refractive index, right? So refractive index is basically the ratio of sine of incident angle divided by sine r, sine of the refracted angle, and that ratio is constant. Okay, that is very, very important. Okay, so that is very, very important. This ratio is constant, and that constant we are calling it as refractive index. Okay, and refractive index for a given pair of media is given by speed of light in medium 1 divided by speed of light in medium 2 equals to v1 by v2. Okay, so and what is this meaning of n21? N21 means speed of light in the second medium with respect to the first medium, right? So n21 represents the speed of light of the second medium with respect to the first medium. Okay, this is how you should read it. Okay, so speed of refractive index of the second medium with respect to first medium. Okay, n21. So speed of light in medium 1 divided by speed of light in medium 2. So whosoever you are finding the refractive index, that is the second medium, that should come in the denominator. Okay, and with respect to which you are calculating, that should come in the top. Now if you want to reverse this, so suppose you want to make one ray travel from this medium to the other medium. Okay, then you can define the refractive index of the first medium as also. So how to define that? Refractive index of the first medium with respect to second medium is speed of light in medium 2 divided by speed of light in medium 1, that is v2 by v1. Now these things are very complicated and difficult to remember, even though sometimes it can comes handy. There will be some numerical, some objective questions based on this, but that will be, you just need to remember that if refractive index with respect to one medium is say x, and then reverse will be 1 by x. This is nothing but 1 by n21, right? So n12 is basically reverse of inverse of 1 n by 2 n21, right? So reciprocal of n21, whatever way you want to say. So this is the easiest way to remember, but these are all complicated things. We don't want to go into complication, so we want to define something which is absolute, which does not change from medium to medium. So that absolute refractive index is given by speed of light in vacuum, which is constant, right? We know that that is c, that is denoted by c, and if you know what is the value of c, don't forget to mention that in the comment below, right? So speed of light in vacuum or air, okay, for the matter of fact vacuum and air are considered to be almost same for speed of light. So speed of light in vacuum or air divided by speed of light in any medium. right? So what information you get from this equation? Okay, first of all, you get from the equation is that n refractive index is always, absolute refractive index obviously, is always greater than equals to 1. Absolute refractive index is always greater than equals to 1. Relative refractive index can be a fraction, it can be less than 1, okay, but it is always positive. But absolute refractive index is always greater than equals to 1. Why? Because we know for the fact that speed of light in vacuum is the maximum possible speed, maximum possible value, right? So any object can have the speed, maximum speed, that is speed of light in vacuum. So speed of light in vacuum is the maximum speed. Any other medium, for any other medium, speed of light is always less than that of vacuum, okay? So numerator is always greater than the denominator. Now in case of suppose you want to find the refractive index of air, or you want to find the refractive index of vacuum, so in that case refractive index will be 1. Okay, so refractive index of air, absolute refractive index of air is 1, absolute refractive index of vacuum is 1. Okay, so that's why I said n is always greater than equals to 1. Okay, so if they ask you can you name one medium which has a refractive, absolute refractive index 1, obviously I know that is vacuum, or also air almost equals to 1, right? So you can answer this question, right? Now let's move on to the next part. Next part is lenses. Okay, so what is the lenses? Lenses is where we are applying the concept of reflection, laws of reflection, and laws of refraction. Sorry for confusion. So what is happening here? So first of all, the ray of light is traveling. Okay, here suppose we have one medium 1, okay, there is some other medium 2, and again the first medium is back on the other side. So this is the lens. Okay, so in between some refraction is happening. There are two lenses, two types of lenses that we are going to study. One is called convex lens, one is called concave lens. Okay, like the mirrors, we have learned that in case of mirrors, right, concave mirror and convex mirror. Similarly, in case of lenses also we will study two types of lenses. Okay, convex mirror and convex lens and concave lens, and they are called spherical lenses. Why they are called spherical lenses? Because if you extend any side, okay, they basically form a sphere, like the spherical mirrors where the edge is part of a sphere. Similarly, if you take two spheres and make them intersect each other, whatever region is left, that is the lens. Okay, so basically spherical lenses are two part of two spheres. Okay, one sphere is on this side, another sphere is on that side. Okay, so this is the two sphere lens. Similarly, here also one sphere is on this side, another sphere is on that side, and whatever the gap between them, you have filled that gap using some material. Okay, so this is concave lens, this is convex lens. I told you how to remember concave and convex. Okay, vex means coming out, cave means going in. Okay, now here also I will describe the definition of focus for lenses. Okay, so definition of focus, if you remember for reflection, okay, light rays, parallel light rays falling on the mirror, okay, after reflection they were either meeting at a point or they were appearing to come from a point. So that's how we define the focus for mirrors. Similarly for lenses, okay, after refraction, now everything happens on the other side. Light rays definitely goes to the other side. Okay, in case of reflection, everything happening on one side only. Okay, light ray is going here, reflecting, coming back. Okay, in case of lenses, all the lights come from this side and they will go to other side. Now how the image will be formed, that is a different question. Okay, where the image will be formed, that is a different question, but light rays will travel to the other side. Now in case of convex lens, parallel rays after falling on the lens, they will actually meet at a point. That point is called principal focus. that point is called principal focus. Similarly, for concave lens, okay, the light ray after refracting, they will appear to come from a point. They will appear to come from a point that is called another principal focus. Okay, now lenses have two principal focuses. Okay, one each on the either side of the lens. Both lenses, all type of lenses, they have two types of focuses, okay, on the either side of the lenses. The easiest way to remember is that in case if you allow parallel light to pass through this side, they will focus on f2. Similarly, if you allow parallel light to pass from this side, they will focus on f1. Okay, similarly, if you allow parallel light to pass from this side, they will appear to come from f1, and if you allow parallel light to come from that side, they will appear to come from f2. Okay, that's why there are two focuses for a lens, but we will only consider the light rays traveling from our left hand side to our right hand side. This is always the norm. Okay, so sign convention is u is always negative. Okay, this is our x-axis, so this is along x-axis. So you remember the sign convention. Anything this is our origin, so anything on the right hand side of the origin is positive, anything on the left hand side of the origin is negative. Okay, anything up is positive, anything down is negative. So that is the new Cartesian sign convention. Okay, now let's move on to the principal rays. Okay, a ray of light from the object parallel to the principal axis after refraction from a convex lens passes through the principal focus of the other side of the lens. In case convex lens, the ray appears to diverge from the principal focus located on the same side of the lens. So if the parallel ray are going here, okay, after refraction it meets at focus. Okay, in case of concave lens, after refraction it appears to come from f1. Okay, so this is the basic difference in between lenses and mirrors. Okay, now should you choose science right now and in future you should focus on engineering, or you should choose science right now and in future you should focus on for doctor examination, etc. So they will clear everything, every doubt that you might have, and you will have a very future focused future path, and you should not deviate from that. You will always converge like convex lens unlike concave lens, right? So if you want to be a convex lens, definitely join DSAT, and if you don't want to be a convex lens, want to be a concave lens diverging away, then do not register for it. Okay, then anyway register anyway, right? Now image formation by concave lens. So in case of mirrors, first we learned about convex mirrors, then we learned about concave mirrors, right? So in case of lenses, we will do the exact opposite. First we will learn about concave lens, then we will learn about convex lens. Okay, so as the first thing, object is at infinity, so ray of light is parallel. Infinity means so far that light rays have become parallel now. Okay, so the parallel rays is coming after refraction. Okay, they are focusing at the principal focus. So basically this is it. So you will get a highly diminished virtual image. Why virtual? As soon as you are drawing back the lines behind the lens, okay, that means it's a virtual image. Dotted line means when you are actually they are not meeting, that means it's a virtual image. So virtual, highly diminished and direct. Okay, now in case of any object between any other point of the lens, okay, any other point on the lens, okay, on the axis, okay, it will be always diminished, okay, erect, diminished and erect. Okay, so this is the way you should draw it. This diagram is okay, not super common, but maybe you should practice. I will tell you how to draw a lens. First of all, you have to take a straight line, okay, then take, in case of mirrors, you just need to put your needle here and draw one line, right? Now in case of lenses you cannot do that, so you have to choose wisely, and you have to choose 2 points, and page should be always horizontal in this case. Okay, you cannot write like you do in your exam, you have to rotate it, okay, in the direction, so that you can use the maximum space in case of lens diagrams. Okay, now first of all you have to take your midpoint. So this is your 0 point. Okay, very important how to draw the lens. Now using your scale, measure a distance, say 3 centimeter, or 3 centimeter is fine. So you measure a distance 3 centimeter. Similarly here also you measure another length 3 centimeter. Okay, now how can you draw concave lens? So to draw concave lens, you should take a radius which is very close to 3 centimeter but slightly less, so 2.9. okay, you need to take 2.9, put your needle here, draw a circle. Okay, it should not be touching it here, but it should be very close. 2.9 is fine. Similarly here also use the same radius 2.9 and draw another circle. Okay, then you join them using another scale beautifully, okay, so that it looks perfect. That will be give you a concave lens. Okay, for convex lens, instead of taking 2.9 diameter, you have to take 3.1 radius. Okay, so not diameter, radius. So instead of taking 2.9, you have to take 3.1, so that it goes on the other side. Now these two you can use them as your focus, f1, f2. Okay, this can be your 2f1. In fact 2f1 is only required for convex lenses. For concave lenses 2f1, 2f2 does not matter. Okay, so this is how you should draw the diagrams. Okay, similar to that of concave mirror, there is also a trick for convex lens. We will learn that, but this is how you should start your ray diagram. This is the starting point of your ray diagram. Now if you summarize that, so when the object is at infinity, okay, position of the image is at focus f1, okay, highly diminished, point size, virtual and erect. Between infinity and the optical center O, between f1 and optical center O, same side, right, diminished, virtual and erect. Okay, so wherever you put the object, image will be also formed on the same side. f1, the numbers should be very important. Okay, anything on the left hand side is f1, on the right hand side is f2, right. Now let's look into the image formed by convex lenses now. So first is object is at infinity, so parallel rays are coming and they should focus at the focus, obviously. Okay, so this is the focal length, this distance is called focal length. Right, so this distance is focal length. Now if you see clearly, okay, everything is happening from this. So what you can do this, you have to draw this line as well. While drawing ray diagram, you need to draw this middle line as well. Okay, it is fine, you can draw this middle line, no problem. It should pass through the optical center. Okay. So this line you should draw, and all the rays after reaching here, they should bend. Okay, so this is very difficult to draw using your bare hand, so I suggest students to draw this line. Okay, this line you can draw, you cannot draw, but this is easy for you to remember it. Okay, you can draw using a dotted line as well. Okay, some books, foreign books, they represent the lens by only a line. Okay, they don't even show the curvature, but curvature is important to denote whether it is a convex lens or concave lens. Okay, now what is the object beyond 2f? You will see the similarity with the mirror as well. So beyond 2f, okay, so in this case image will be between f2 and 2f2 and it will be diminished. Okay, so basically as I told you one example, that you started walking from infinity towards the lens now. Okay, convex lens is there, you started at infinity, now you are slowly walking towards the lens. Okay, so as you are walking towards the lens, okay, your initial first image, first one, when you are at infinity, the image size was point size, very small, diminished, real but very small and diminished. Right, now as you are progressing towards the lens, now the image size is no longer point size, it is slightly bigger, but it is still smaller than your original size. Okay, so it is still smaller than your original size, but obviously it is not highly diminished, it is only diminished in this case, it is inverted. Okay, the arrow is inverted now, and you have to learn how to draw this parallel ray passing through this. Now they have they have shown the dotted line here, they have shown the dotted line here. Okay, you can draw the dotted line in both cases. Okay, so the ray of light, after passing through it, they have passes through the focus f2, and after passing through O, it has gone straight, and whenever they have interfered, there you get the image. Okay, so this is the inverted image, real image, and the distance of this is called object distance, u, as same as in case of lenses, and the image distance is v, and the focal length is f. Okay, now you remember that in case of concave mirror, okay, focal length was negative, and for convex mirror the focal length was positive. The same thing is here. Okay, even though the property of images produced was changed, for convex lens focal length is positive, for concave mirror focal length is negative. This case they are exactly the same as in case of mirrors. Be it concave mirror or concave lens, focal length is always negative. Be it convex mirror or convex lens, focal length is always positive. Okay, these things you have to remember in your head. Even though the property of images, convex lens has similarity with concave mirror, but focal length wise they are not similar. Okay. Now object is at 2f. Now as you started walking towards the lens, now you have reached some point where you are seeing that the image formed is exactly of your size. So that is 2f. So image started at 2 point image, then slowly it started increasing, and then it has become exactly to your size. Okay, how to draw that? Obviously the trick is first draw the object. I already taught you how to do that for mirrors. So lens you have to draw. Okay, lens I told you, take the focal length. Say suppose this length is 3 centimeter. Okay, you have to use 3.1 centimeter. Draw this arm, then another 3.1 centimeter. Draw this arm. Okay, this should be your 0 point. So take the scale. Okay, take the scale, put here 3 centimeter, here 0 centimeter, here 6 centimeter. At one go every point will be marked. Okay, draw the straight line then. Okay, then put the needle here and then draw 3.1 centimeter here and put the needle here, 3.1 centimeter on this side. Your lens is completed. Now this is your 3 centimeter, so this will be 6 centimeter. Similarly here also it will be 6 centimeter. Okay, in this case focus is not something fixed, you can choose on your own. Okay, in case of mirrors the distance was fixed because CEF they are already fixed. In this case you can take representative focus, representative 2f, does not matter. Okay, so now what you will do, you take this arrow. Suppose you take an arrow of 2 centimeter, you draw another arrow here reverse with 2 centimeter. Okay, now you take this ray, okay, parallel, then you join this point and this point. Don't draw them randomly, join this point and this point. Similarly you take scale, join this point and this point, try to match it as much as possible with optical center. It will be slightly off. Okay, you can highlight that with a large point, a large dot, and mark it as O. Slightly off, it will maybe there is a possibility it is slightly off, but this will be very off if you are not doing like this. Okay, so first parallel, then join this and this. Wherever this line intersect this, you mark this as F2. Okay, so this is the trick. You should not mark F2 for this position. For any other position you mark F2 like I taught you. Okay, so you take to 3.1 and mark F2, mark F1. Okay, if you need any detailed video on how to draw ray diagram, let me know. I will try to bring some pencil and compass and I can try to show you hands on. Okay, but you have to mention that in the comment. Next is object is between 2F1 and F1. Okay, so object is between 2F1. So as you have started walking, your journey still continues. Now you have reached, you have crossed 2F1. Now you are between 2F1 and about to reach F1. So at this point your image is now enlarged. Okay, so till this point your image is less than equals to your image, your size. Now after you crossed 2F to F1, your image size is slowly now started increasing. Okay, now as you reached exactly at F, now your entire rays are now parallel and you are getting a hugely enlarged image, but it is forming at infinity. Okay, so when you are standing in front of focus, okay, your image is getting formed hugely enormous, but that is exactly forming at infinity, so you cannot see that. Next is now you have crossed the F threshold and now you are between optical center O and focus, first focus. Then what will happen? Now in this case you will get a virtual and upright image, virtual and erect image, and it will be behind the object, that is on the same side of the object, and it will be virtual image. This is a virtual image, this is upright image, it is enlarged image. Okay, this property of lenses is convex lens is used in spyglass, okay, or reading glass, where if you put a convex lens in front of an object very close to it, it appears bigger. right? You have seen that. So and many movies, Sherlock Holmes movies, they actually show that just using that lens you can become a spy, right? So that is a spyglass, or also called magnifying glass, okay, because it can magnify small objects into big, right? So that is how it is used. This is the property which is used in magnifying glass, okay. So this is the table. You can remember the table: at infinity, at focus f2, highly diminished point size, real and inverted; beyond 2f1, between f2 and 2f2, diminished, real and inverted; at 2f1, at 2f2, same size, real and inverted; okay, between 2f1 and f1, beyond 2f2, enlarged, real and inverted; at f1, at infinity, highly enlarged, real and inverted; between O and f1, same side as the object, enlarged, virtual and erect, okay. Now lens equation: 1 by v minus 1 by u equals to 1 by f, okay. In case of mirror equation, it was 1 by v plus 1 by u. In this case, 1 by v minus 1 by u. You have to remember the difference, okay. And this formula is valid for all situations, for all spherical lenses, for all positions of the object, okay. There is no exception. This is common equation, okay. Only thing that you have to take care of, that you have to use the new Cartesian sign convention, okay, where the object is, where the image is, which type of lens it is. Based on the sign convention, if you are putting the sign convention perfectly, you will always get a correct value. Now what is the magnification? Magnification is height of the image by height of the object, v by u. So in case of mirrors, there was a negative sign. In case of lens, there is no negative sign. That's it. That is the basic difference. In case of mirror, magnification is denoted by a negative sign. In case of lenses, magnification does not represented by a negative sign. But if the value of magnification is negative, that means image is inverted, and that means image is real, right? And if m is greater than 1, then image is enlarged. If m is less than 1, m is diminished, okay. Clear? So let's see the example problem. A concave lens has focal length of 15 cm. At what distance should the object from the lens be placed so that it forms an image at 10 cm from the lens? Also find the magnification produced by the lens. So first of all, it's a concave lens, so its focal length is negative. Focal length is minus 15 cm, okay. Now at what distance should the object from the lens should be placed so that it forms an image at 10 cm? In case of concave lens, we know that it forms a virtual image. So virtual image is on the same side as the object, so image distance will also be negative. So minus 10. We will find u. Don't worry about sign of u. We will get the sign of u correctly if we solve the problem properly. So what is the formula? Formula is 1 by v minus 1 by u equals to 1 by f, okay, or 1 by v is minus 1 by 10, minus 1 by u equals to 1 by minus 15, okay. So you can see that all the terms in this equation are negative, so you can take negative common and cancel them. So you will get 1 by 10 plus 1 by u equals to 1 by 15. Okay, so all the negative signs are taken common and then cancelled. So what is 1 by u now? 1 by 15 minus 1 by 10, that is 30 is LCM. 15 to the 30, 3 10 the 30, so 2 minus 3, or 1 by u equals to minus 1 by 30. Okay, so u equals to minus 30 centimeter. So you have to place the object 30 centimeter away from the lens. Okay, now what is the magnification? Magnification is given by, for a lens, magnification is v by u. So it is minus 10 divided by minus 30 negative negative cancels, so it will be 1/3. So the magnification is 1/3, so object is diminished. Okay, clear? Simple problem without any difficulty, you should be able to answer this, right? Now let's move on to the power of the lens. What is power of the lens? The degree of convergence or divergence of light rays achieved by a lens is expressed in terms of its power. The power of the lens is defined as the principal of its focal length. It is represented by the letter P. The power P of the lens of the focal length f is given by m. Some mistake is here. This is not the power of the lens. Power of the lens is P equals to 1 by f. Okay, P equals to 1 by f. Now here the SI unit of power of a lens is diopter. It is denoted by the letter D. If f is expressed in meters, then the power is expressed in diopter. So we have to remember that power is basically 1 by f. So when f is in meters, okay, especially when you are representing that using the unit diopter. Okay, so basically in our day-to-day life, whenever you are seeing a focal length, that is being denoted by centimeter. So if you want to find the power, you have to first convert it into meter by dividing that with 100. We will see within one example. What is the example? How are power and focal length of a lens related? So we know that power and focal length is related by f is equal to 1, p is equal to 1 by f diopter, where f is in meters. Very very important. Okay, you are provided with two lenses of focal length 20 centimeter and 40 centimeter respectively. Which lens you will use to obtain more convergent light? So let's find the power of individual lenses. Okay, power of lens 1 P1 is basically 100 by 20. Why 100 by 20? So 100 means you have to convert into centimeter, right? So convert into centimeter, you have to divide by 100. But in this case, when you are calculating the power, it is already divided. So 100 will go up. Okay, so what I am saying is f is equal to 20 centimeter, that is 20 divided by 100 meters, right? So power will be 1 divided by 20 by 100, or it will be 100 by 20. So in general, so there is a shortcut way to convert focal length into power by directly dividing that focal length to 100. Okay, so if you directly divide 100 with that focal length, you will get directly the power. So power is 5 diopter. Now what is P2? P2 is 100 divided by 40. The second focal length is 40 centimeter. So 0 0 cancels. So you will get 2, 5, 2.5. So 2.5 diopter. So the focal length of this second lens is 2.5 diopter. Higher the power, higher is the converging power. So you will use the focal length lens of focal length 20 centimeter for higher focal length, right? So or to obtain more convergent light. To obtain more convergent light, you have to use the lens with higher power, right? So this is the thing. So to use higher power, that you have to use 20 centimeter focal length. Okay, now this is the homework for today's lecture. Okay, so let me read the question. Absolute refractive index of glass and water is 2 by 3 and 3 by 4. Okay, so glass, it is not 2 by 3, sorry, it will be 3 by 2. Absolute refractive index of glass is 3 by 2 and water is 4 by 3. Okay, absolute refractive index of glass and water is 3 by 2 and 4 by 3 respectively. If the speed of light in glass is 2 times 10 to the power of 8, okay, 10 to the power of 8 meter per second, the speed of light in water is. You have to calculate the speed of light in water. Okay, try to calculate this and let me know the answer. Next is, a convex lens of focal length 20 centimeter can produce a magnified virtual as well as a real image. Okay, is this a correct statement? If yes, where shall the object be placed in each case for obtaining these images? Okay, so first of all you have to say if it is correct. If it is incorrect, then you have to mention that only this is correct, and for that you have to do you have to place the image here. If you say both no, the statement is correct, then you have to mention for which of the places you should put the object to get a real image and a virtual image. Okay, clear? Direct question. And if you are still not able to understand what to do in your future, I am saying it for last 20 minutes that you have to appear for Diksha Scholastic Aptitude Test to get a way towards your future. Okay, so what you have to do, you have to visit one of our campuses every Sunday, and there you have to take a 60-minute class. Then based on that class there will be a test. Once the test is over, there will be a counselor. He will guide you to get your dream future. And for that, actually you don't have to visit our campus right now. What you have to do, you have to fill your name, your email, your phone number, class, okay, and submit it. Okay, our representative will contact you and they will schedule an appointment so you can come at your own time. Okay, so if you are still confused about your future, whether to study JEE or whether to study NEET, whatever your goal is, that goal, whether you are ready for that goal or not, so Diksha Scholastic Aptitude Test will guide you towards that goal. Okay, so I'll be back with a new lecture of previous year questions from this entire chapter tomorrow. Till then, bye.